All right. Good morning, class. Glad to see you all again. I hope that you guys enjoyed trying on that factors and multiples lesson that we had tried on earlier. The really nice thing about it is that, just one second, I'm going to close my printer because it's being a little loud. All right. So, good morning, class. I am so glad to see so many of you tried on the factors and multiples lesson from the other day. It definitely does my heart well to see that many of you guys are still learning and working hard and just doing your best. We really, really appreciate it. So today we're going to have another day of factors, looking more specifically and kind of playing around with some different things to really understand what factors are. So our learning target today, and this is taped on here pretty tight, so I'm going to read it to you. And if you can see it, that's awesome. Read it with me. If not, just listen up. It says, today we are learning how we will create arrays, rectangles, of a number and determine factor pairs. So factor pairs is a new term we're going to go over. And after much searching, I found a better definition for factors. And so we have a new definition for factors as well. So our vocabulary today includes factors, and factors are numbers you can use to multiply to make another number. Numbers you can use to multiply to make another number. So if we are doing this with the word factors, I would say we want to do TPR, because we have always talked about how TPR helps it remember helps our brains remember exactly what we want it to. So what we're going to do, factors, numbers you can use to multiply to make another number. So factors, numbers you can use to multiply to make another number. It's not a perfect science, it's just doing the best you can in order to help your brain remember. Our second vocabulary today is factor pairs. And factor pairs are two numbers you multiply to make a product. So two numbers you multiply to make a product. So pretty similar to the word factors, but a factor pair is two numbers that together will make the numbers. Kind of like our part wholes we've talked about before. Now, as we are working today, and as you continue to work, we are going to continue to work on the San Francisco kind of math behaviors we want to keep up with. We have some different things because you guys are all amazing mathematicians. And sometimes to be a mathematician, it doesn't mean you can do the most multiples in 30 seconds, or you can divide 12 by 14 numbers. Sometimes being a mathematician is just trying your best, persevering, and understanding what math really is. So our norm that we're working on today is answers are important, but they aren't the math. Oh, it's a little low, but they aren't the math. So the reason I chose this one is because we are working with factors and multiples and really understanding that, yes, there will be an answer. There will be what the factors are. We will eventually know what multiples are. But it's so important to understand how you got those, how they make sense, and not just be able to rattle off numbers. The process of it is very important. So for your assignment today, you are going to be working with arrays. Arrays is a term we have not used for a while, but an array is sort of like a box made of smaller boxes that can help us multiply, help us add. Sometimes we see arrays with dots that are placed together. What you're going to be doing today is you're going to be finding factor pairs using arrays. I'm going to give you a number. For example, if I was to have the number 15, and I'm going to do the best I can, this is small graph paper. So I will also be showing you an example on the screen. But if I was to have 15 and I wanted to make an array of 15, well, what I could do is first think of, okay, factors of 15. Well, I know all numbers have at least two factors, those factors being 1 and themselves. So 2 factors of 15 I know are 1 and then 1 times 15. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then in order to complete my array, I'm going to continue to outline this like that. And then I'm going to label it. I've got 1 by 15 here. And I know I'm going to label it in the middle. 1 times 15 equals 15. Now, I'm going to see if there are any other ways that I can make the number 15. So for example, I know 3 times 5 is 15. 1, 2, 3, and I'm going to go over 1, 2, 3, 4, 5. Then I'm going to finish my array. What I'm going to do here now is label it 3 times or by 5, and then I'm going to fill it out in the middle. 3 times 5. If I was to count all the boxes in here, I would get 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If I had more than 15 boxes in there, it wouldn't be an array. It wouldn't be the kind of arrays that we're using. So one way, if you're trying different things out, is if there are more than 15 boxes in there, it's not an array. The other thing is, if you try something like thinking, okay, I'm going to go 2 times, let's see, 1, 2, 3, 4, 5, 6, 7. Well, let's see here. On here, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14. Well, I need 15, so I'm just going to add a box right here. That's not what we want to do. Those aren't the arrays we're looking for. We want even arrays because factors go into their product evenly. I'm going to switch to my screen now so that you guys can see an example on what you're going to use for Seesaw.